What's up, guys? All right, we're going to the law of conservation of energy. So just a little bit from physics, okay? But we're not gonna get to like the like a crazy detail, just like a surface talk about this. All right, now this law state that you can make an energy, you cannot destroy it, but energy can be transformed from one energy form to another energy form. Okay, you can make it, you can destroy it. It can transfer from one to another. Give you some example right here. Let's say if you're on a bike, okay, at on top of the hill, and you stop right there. And when I say stop, it means you're not moving. You have no velocity, so kinetic energy is zero. Okay, and at this point, the potential energy is at the highest. If you still remember when we talk about potential energy, we need a reference point, and the reference point is at the bottom, at the ground. Okay, you are at the highest position in this system, so the potential energy is at the highest. All right. Now you come down the hill. Let's say, keep things simple. You are halfway up the hill, halfway down. Of course, obviously, you're moving, so you have some kinetic energy, right? But according to the law of conservation of energy, the energy has to come from somewhere. You can't make it, you can't destroy it. It has to transform from something. From where though? The potential energy at this point, you're not as high as the first position, right? So the potential energy is lower, and the other half of potential energy was transformed to kinetic energy. That's why you're moving. Okay, and at the bottom, you can guess now that you move at the highest speeds, highest velocity. So, but at this point, you have no potential energy because you're at the ground. Okay, and all potential energy is transformed to the kinetic energy. All right, that's how it works. All right, now let's try this one. Another example. So if you don't really get what I said earlier, try one more time. So right now, this string, look at this string right here, is stored an energy, elastic potential energy. Where does this energy come from? If you want to get to the detail, it's start from chemical energy in your body. Bicep, tricep help each other pull the string. Okay, so that's from ATP. And as you pull the string, that you do work. So work is an energy that to move objects for a certain distance. Okay, so the chemical energy is transformed to work, and work transformed to elastic potential energy in the store in the string. Right. So basically, in this example, the chemical energy is transformed to the elastic potential energy. Okay. All right, give you some more example. If you move your hands like this, watch me right here. Right. So you are producing heat from your hand. And this heat comes from start with kinetic energy, so you move your hand like that, okay? Or it comes from chemical energy in your body, so you can move your hand and then you produce heat from doing so. All right. This one, another example of using chemical energy and transform it to light and heat. Another chemical energy in the battery, right, and transform it to electrical energy. Okay. All right, let's do this together. So concept test, if you toss a football up to the air, does the kinetic energy increase or decrease as it moves higher? Well, start with this. So if you throw the ball up to the air, the ball moves at the fastest speed when it leaves your hand, right when it leaves your hand. Okay, so right now high kinetic energy, but it's just that the reference point is your hand basically. So potential energy is small, really slow, little small. As the football moves up higher, and you can imagine that it goes slower, right? So the kinetic energy is transformed to potential energy. So we have lower kinetic energy at the top. As it moves higher. So to answer the question, does kinetic energy increase or decrease? So decrease as the football moves higher. Now another one. So arrange the potential energy for each point of the pendulum. So we have A, B, C, D, and E. From the highest potential energy to the lowest potential energy. Okay. All right. Speaking of potential energy, we have to set the reference point, and the reference point in here going to be the C level right here. All right. Let's assume so A and E are at the same level. They kind of crooked a little. All right. So let's say A and E are at the same level. So A and E will have the same potential energy and the highest, followed by B and D, and then C. Go like that. Okay. All right. We have class activity number 2. Just remind you when you answer this question, you put on a piece of paper, take a picture, scan, and then upload it, right? And when you answer, if you answer in question 1 is A, don't forget to write A and then air, or C and sunlight. Okay, just to prevent you from getting confused. Just answer A, but you meant sunlight. So that doesn't make any sense. So make sure you do that. So A and air. So question 2, if you answer C, so write down C and metaphysical. Okay. Sometime, and you'll see much later in the later chapter, sometimes I'll give you the answer key, all right? But you have to explain it, or I give you the key, the number, but you have to show the calculation. Okay. We have question 1, question 2, 3. You have to explain this one, and 4. I give you a hint. Okay. All right. Let's move to the next video.